musculoskeletal injury risk assessment in a car dashboard assembly line using various quantitative and qualitative tools. And the paper is presented by Mohamed Reza Bahmani.
Hi, can you hear my voice clearly?
Yeah, we can still see.
Okay. I'm going to turn off my webcam because my internet connection is not perfect and it may cause interruptions, and after that I will turn it on again for question and answer part. Hi, I'm Mohamed Reza Bahmani from Sharif University of Technology, the presenter of the paper Musculoskeletal Injury Risk Assessment in a Car Dashboard Assembly Line using various quantitative and qualitative tools, which is in the field of occupational biomechanics under the supervision of Professor Navid Arjmand. Work-related musculoskeletal disorders are great challenges for automotive manufacturing industries due to exposure to various physical risk factors, especially during manual material handling tasks like carrying, lifting, pushing, pulling, and lowering. Low back pain is the most common musculoskeletal disorder among people worldwide. In previous studies, the causal association between manual material handling and low back pain, which is, as I said, the most common musculoskeletal disorder, has been found. Various ergonomic risk assessment tools are developed to evaluate the risk of musculoskeletal injuries. These tools are divided into two main categories. First, qualitative ergonomic tools that use a set of work-related parameters such as load weight, vertical or horizontal hand load distance, and task frequency to estimate the ergonomic risk. Second, quantitative tools or biomechanical models that are capable of estimating the spinal loads, particularly in the lower back. And by estimating the forces, they predict the ergonomic risk of the tasks. A previous study on the employees of Iran Khodro Corporation, IKCO, a well-known car manufacturing industrial group, shows that in a developing country such as Iran, low back pain is a common problem in the working population. Recently, the task of lifting, carrying, and lowering the car dashboard in the assembly line has shown a high prevalence of musculoskeletal disorders in the employees of IKCO. So the present study aims to assess the risk of musculoskeletal injuries in workers during dashboard assembly job tasks and propose cost-effective administrative and engineering interventions to reduce the ergonomic risk factors. In the first part of talking about the study methods, I'm going to talk about the tasks and the context of study. The dashboard assembly workstation was selected for task assessment as the prevalence of musculoskeletal discomforts in the workers of this job was acknowledged before. Job tasks in the workstation included repetitive motions, forceful exertions, and awkward postures, which were grouped into three main sequential tasks: lifting, carrying, and lowering the dashboard. Lifting was carried out by two workers from a knee-height stand. Both employees performed carrying within a 10-meter distance from the stand to the automotive in the assembly line. And finally, lowering the dashboard in the automotive chassis was performed alone by either of the workers from the passenger's side. Moreover, the front car passenger doors had been mounted on the automotive beforehand due to a defect in the assembly line design. So the worker's space was restricted to lower and install the dashboard. The automotive dashboard weighed 23 kilograms and had a length of 140 centimeters. The center of gravity was estimated to be located 55 centimeters from the driver's side, showing that the dashboard is heavier on the driver's side. In this part, I'm going to talk about the procedure that we followed for collecting data. Accurate motion analysis via inertial sensors or other skin-based optical devices was not possible due to the imposed security restrictions by IKCO during the pandemic. Therefore, we used a replacement method to measure the subject's posture and extract anatomical joint angles. First, we took several photographs from each worker performing their assigned tasks. Subsequently, a different individual imitated the real worker's postures carefully in a proper situation, and we took two photographs from perpendicular planes, I mean the front and side views. Then we analyzed front and side view photographs using Digimizer image analysis software to determine the 3D coordinates of some essential body joints. Eventually, we imported the 3D coordinates to the Anybody modeling system, and we tried to minimize the distance between the model joints and the imported points, and the workers' postures were modeled in software. Furthermore, the anatomical angles of body segments were extracted from this model and used as input into all assessment tools. Here we can see the whole process of the replacement method that we used for data collection. Taking real pictures, imitating the posture, extracting joint coordinates, and modeling in Anybody and extracting joint angles. We used several tools in order to evaluate the risk of musculoskeletal injuries, 8 quantitative and 9 qualitative tools. Here I'm just going to name them. The quantitative tools are Anybody modeling system, 3D SSPP, regression equations, CATIA, JAC, HCBCF, LSPM, and simple polynomial. And the qualitative tools are NIOSH, RULA, REBA, WISHA, LAFFT, MAC, OWAS, MANTRA, and V3. Some of these tools have their own unique classification methods to score the risk factor. In contrast, others do not provide any threshold values for their output, and they leave the interpretation to the user. Consequently, to have an overview of the findings of the assessment tools altogether, we reclassified the risk levels of the tools into 3 levels: the safe zone, the risk zone, which requires ergonomic attention, and the danger zone that demands immediate ergonomic interventions. These risk levels are demonstrated by 1, 2, and 3 respectively in the table. To evaluate the risk of musculoskeletal injury in the workstation, we first used some of the quantitative tools like Anybody modeling system, the predictive regression models of Arjmand and colleagues, 3D SSPP, and JAC, to identify the critical task in the sequence. The worker is the most vulnerable to the ergonomic risk factors during the critical task, in which the spine is subject to the highest intervertebral disc compression force. The maximal L4-L5 compression load, as evaluated by 3 out of 4 quantitative tools, occurred during the lowering task, showing that lowering the dashboard is the critical task in the sequence. Once the critical task was detected, we used all the aforementioned assessment tools to evaluate the risk of injury in the critical task. Apart from HCBCF, other tools showed considerable injury risk on at least one body segment in the critical task. Moreover, all quantitative tools but 3D SSPP reported a potential chance of violating the safe zone in the lower back. Workers tended to take down and mount the dashboard from the passenger side door. Changing this direction to the driver's side door resulted in smaller external moments on the low back and caused significant changes in the risk levels as suggested by most of the quantitative tools. In contrast, qualitative tools were not sensitive to this intervention, and they suggested risk status didn't change significantly. If the doors are not mounted, one worker is not forced to carry and lower the dashboard alone. The whole task can be done in a twosome, and the risk of injury will decrease. All quantitative and qualitative assessment tools, except LIFFT, reported a safer state when lowering the dashboard was carried out by both workers. And here the bar chart compares the L4, L5 disc compression load in the lowering task using all quantitative tools before and after each intervention. The considerable reduction in the forces is evident in all of the tools. Well, we aim to estimate the general risk of musculoskeletal injury during lifting, carrying, and lowering a car dashboard by utilizing various quantitative and qualitative ergonomic risk assessment tools. And we also wanted to propose efficient administrative and engineering interventions. The lowering task was identified as the most critical task where the largest spine compression forces were predicted. And we suggested two engineering interventions and one administrative intervention to reduce the risk of injury. The dashboard rack stands were located on the right side of the automotive due to the assembly line design. Therefore, the workers had to put down the dashboard from the passenger side. The dashboard center of mass, as I said, is located further towards the driver's position. According to our findings, changing the side of the task provided smaller moments at the intervertebral discs as the center of mass of the dashboard was closer to the worker's body. As a result, the ergonomic risk levels in the modified task, after intervention 1, were reduced in most of the quantitative tools. In contrast, qualitative tools showed changes only in a few cases. Moreover, implementing this engineering intervention to the car assembly line will decrease the ergonomic risk at relatively low cost and minimum structural changes by transferring the rack stand of the dashboard to the opposite side of the workstation. According to IKCO supervisors, the assembly line will be modified immediately in a way that the doors would not be mounted on the automotive before the large parts, like the dashboard and the seats, are mounted. Therefore, we carried out risk assessment for the pair work lowering task to ensure that the critical task was safe enough. Removing this fault from the assembly line design allows the workers to perform this task as a pair work, thus providing a more efficient load distribution and eliminating the awkward posture. While changing the assembly line structure can be costly and time-consuming, the modified task will be completely safe. Besides the engineering interventions, we suggested easily attainable administrative interventions to the workstation supervisors. Since the critical task used to be carried out by one single person, a change of plan was proposed. So each worker would swap position in the task after each complete cycle. This intervention is called job rotation and can reduce the worker's fatigue caused by load. In conclusion, in this study, the dashboard assembly task in the IKCO automotive assembly plant was assessed using several quantitative and qualitative risk assessment tools. Results indicated that the critical task in the assembly sequence was the lowering task. Therefore, we proposed feasible engineering and administrative interventions to reduce the exerted load on the worker's low back. This is the end. Thank you so much for devoting your time to this presentation, and I'll be waiting to answer any possible questions.
Thank you for this presentation. Very interesting. We have a minute for questions for the audience. Some colleague or student wants to ask something.
May I have a question?
For sure.
Of course.
I wondered that the number of repetition, did you consider in the muscle injury assessment or not?
Actually, some of the tools consider the fatigue and the number of repetitions during the cycle that the worker is in the workstation. For example, LA50 tool considers this issue, but there are some other tools that they don't consider fatigue and the frequency of the task. So everything is up to the tools that we are using. Some of them consider it and some other neglect.
No, I mean that the muscle injury comes from the overloading a muscle or overloading the body that can be assessed by these tools or not.
Yes,
Not
yes, for sure.
just stress.
For sure.
So
As I said,
you didn't do these experimental studies in your, or you haven't found any muscle injuries in the company that you work with.
actually, in the field of occupational biomechanics, the emphasis is on low back. But there are some tools, some quantitative tools, like any body modeling system that you can see the picture here, that they really calculate the muscle recruitment and the muscle forces. For example, as you can see on the right shoulder of the worker, we can see that the color of the muscles turned into purple, and it is an indication of that there is a severe injury risk level in this part. So yes, some quantitative tools can measure the muscle forces, but some others can't. For example, a 3ds SPP tool, which is belonging to Michigan University, I think, it only gives us the force that is exerted on the intervertebral discs and mainly L5S1 intervertebral disc.
Thank you.
You're welcome.
For your answer. Other questions from the audience? So I think that we can close this presentation, and I give you the floor, Professor Ali Nizari.
Okay, the next and the last talk is about the effect of jawbone quality and